So to show that A plus B grouped that way plus C is the same as A plus B plus C grouped that way, where A, B, and C are n by n matrices. And we'll assume, as in the problem, that the entries are in real. Okay, they are real numbers. So how do you show that? Ultimately, we need to go back and look at the associativity of addition in R, and this is how you might do it here. So let's say the ij entry of A is some aij, and again, this is typically how you delineate or demarcate the row, and this index stands for the column, right? And you assume that ij entry of B is some bij, and similarly ij entry of C is some cij. And now let's look at the left side, A plus B grouped that way plus C. If you look at the ij entry, if you look first of all at what you get in the ij position when you do A plus B first, you get aij, the entry in A, plus bij, the entry in B. You take that, whatever real number that represents, you add to that the entry in the ij position of this matrix C. And that's, of course, cij. So now you know how this is going to go. If, on the other hand, if you were to have done your addition in this form, the ij position of this entire sum would be gotten by, first, you would get the ij entry out there of this matrix, B plus C, and that is given by bij plus cij. You take that real number, and to that you would add the ij entry of this matrix A, and that of course is aij. And you would add it, you could add it afterwards or add it before, it doesn't matter because addition is commutative in the real numbers. And now these are entry by entry, the values in the ij slot when you go A plus B plus C in that order, and entry by entry in the ij slot when you go A plus B plus C in that order. Now all you have to do is observe that these two expressions are equal, and the reason for that is the associativity of addition, and this time it's the addition in reals. That is not so much in the matrices, which that's what we're trying to prove, but we know that associativity of addition holds in reals, and that is what tells us that this expression here, this entire expression here, equals this entire expression here. So this is prototypical of how you would use the associativity of addition or the commutativity of addition, whatever, in the reals, just show corresponding things for the ring Mn of R, matrices of size n by n over R, or for that matter, over rings of the form R adjoined with X, X is a polynomial ring, and so on and so forth.